everyone. My name is Gaurav Kaul, and today I'll be talking about what the AI strategy and platform from HPE would look like in the near future. First of all, I want to apologize because I'm not going to cover anything related to Cray. Marketing wasn't, let's say, that keen on sharing some of the Cray slides right now. Supercomputing is coming, and I think most of you will be there. So yeah, we'll have more information then. So I guess I'm preaching to the converted here that AI has really come up in a big way in a lot of sectors of our economy, and in HP we are working with quite a few of our customers in these different verticals, whether it's with F1 racing teams or with in context of manufacturing or in smart cities or smart factories, to essentially allow us to use AI both on the edge as well as in the data center. And I think Mark and Nick talked a lot about this, that we are seeing some kind of convergence between AI and HPC, at least on the infrastructure level, though it's not there at the moment on the software workflow side or even on the application side, but definitely on infrastructure we are seeing requirements for more and more storage and compute. And that's the area that we want to kind of address to accelerate AI. And I would say the 4 pillars of our strategy really are to, first of all, to allow more DevOps-like sort of culture in AI. So essentially what that means is, and some of you must be familiar with DevOps, is that both development and operations team work together side by side in an agile manner to make deployments go faster. And this was pioneered by a lot of cloud service providers. We are seeing similar culture come into AI and machine learning space. Some people call it MLOps, etc. And the main area really here is to make sure that the software stack is agile enough and flexible enough to support all the different machine learning workflows that are there. And I will go into this in some detail. The second thing is, and some of you might come from data science background and might be aware that how fragmented this space is. Of course you have Jupyter Hub and so on, but you will have Spark has its own machine learning libraries, TensorFlow is its own world, PyTorch is completely different, etc. And then you have to support different infrastructure in terms of GPUs, in terms of other hardware. So that becomes very time consuming. We have customers who can take something like weeks to provision a machine learning or analytics sandbox. What we are trying to help them is how can they do the same thing in hours or minutes even. That's the second thing that we are trying to achieve through the Blue Data software stack. The third piece is how do we allow these AI models to scale, essentially on HPC hardware, and this is where the Cray portion comes in. Of course, we have our existing HPC portfolio, the Apollo, the ProLiant, and from SGI, and a lot of our customers are using that with Apollo 6500 with 8 GPUs, and soon we'll have 16 GPUs in a single chassis. But obviously, at that high end, Cray really fills in that gap. So that's how, and all AI is not really at the is in the data center. It's also at the edge. If you think of things like smart cities or autonomous vehicles and so on, and that's where we have the Edgeline portfolio. And the last thing is really even though as ODMs and OEMs we may not like this, but pay as you go pricing is here to stay, and this is what we are trying to achieve through our GreenLake offering, to allow pay as you go pricing to our customers who want to switch from capex to opex. This is a culture change, and this is where, as Pointnex, I'm part of HP Pointnex, we are allowing that transformation to happen within organizations. So really, in a single statement, the vision is really to transform the deployment and consumption using a hybrid cloud strategy. And I use the word hybrid cloud, in fully understanding the repercussions that as an ODM OEM it has. But this is what our customers want, and this is what we intend to deliver. So I talked a little bit about this. Essentially, if you look at not just AI or machine learning, but across your infrastructure, edge, core, and cloud. These are the 3 sort of main infrastructure silos, if you like. And and the software stack needs to span between the core, the cloud, and the edge even. So this is where HP made an acquisition. Actually, a few acquisitions were made. One of the acquisitions was of a company called Blue Data, which has a software called Epic, which essentially allows creating analytic sandboxes, doing training, inferencing, etc. On-prem or in cloud. And this is what we are trying. This is what we are working with our customers on. And the second acquisition was of a company called MapR, which actually is not an acquisition. I think how it was said was that acquiring the assets of, and I think it would require a lawyer to explain what it means. But essentially, it is we are acquiring the MapR file system, and I will come to it in a second. How it helps us create a data lake for our machine learning workloads. And of course, we fulfill the infrastructure through the existing portfolio that we have of Apollos and Edgeline, and in future of Cray and other software hardware as well. So, so the key problem that we are trying to address is that operationalizing ML models is really difficult. I think was it Nick or Mark who were talking about all these different libraries, different systems, different compute engines, and this is the reason why Hadoop had a very difficult time because Hadoop vendors had a difficult time because you had all these different MapReduce, Spark, all these different compute engines to support, and creating a coherent stack on that. That's what they tried to do, and that's what we are trying as well. But the idea here is that we should be making this a self-service sort of experience. Think of it like as cloud on-prem hardware. So how do we make this happen? Just as a workflow, and the data scientists in the room must be familiar with this. And this is where I think one of the key differences between data science and HPC is that data science has this tightly iterative, sort of almost real-time feedback loop of build, train, and deploy, and monitor your machine learning models. And of course, having the relevant data security and governance in place, especially if you're dealing with sensitive data. And this is generally not what we see in HPC space, but closing this loop is what we are trying to do through Blue Data and MapR. So how do we do this, essentially? So as part of the strategy, we have a platform called HPE ML Ops. This is the new name for the Blue Data stack. So I will refer to them interchangeably. So what we are trying to do is, as I was saying, the DevOps model of CI/CD, building containerized sandboxes environments. This is something that we are enabling through Blue Data. So essentially, all the software is delivered in the form of Docker containers. I will come to Singularity in a second because that might be of interest to the HPC folks here. We provide a different set of, we are agnostic to the underlying tools of machine learning, whether you want to spin up a Cloudera cluster or, a TensorFlow cluster, that's absolutely up to you. Essentially, this is just a Docker file. You just take a Docker file, do a Docker build command, and, you get a Docker container. Then the idea here is that you can then train it, either, training in the general sense of the word, not just in deep learning context, but whether it's in, Spark or TensorFlow or just standard classic machine learning training. But idea here is that you need to have compute and storage that you provision on the fly. And, this is not just for one particular user. You could support multiple users. So you can have multi-tenants essentially using the same cluster. So how do you provide the required isolation between all these tenants? The third is the deployment phase, and this is how you, once you have trained the model, how you create a HTTP endpoint which can then query that model and come back to you with this, come back to you with the predictions and auto scaling and load balancing, which is very much what cloud-like environments provide. And then monitoring. This is key in machine learning, and this is something that very few companies are looking into, or there's an entire ecosystem of startups in this space, but I've not come across anyone who can do this in an end-to-end fashion. And this is exactly what HPE ML Ops as a platform, or Blue Data, tries to do. So what does it look like? So essentially, if I go from the top to down, we can have different personas of users. They could be data engineers who are doing data prep. It could be data scientists who are just doing this build, train, deploy, and monitor sort of in a tight feedback loop. Or it could be ML architects who are creating the platform, if you like, the relevant hardware blocks and the software stack and the middleware for this. HPE ML Ops provides access to all these personas of users. And we support, as I mentioned, we are agnostic to the tooling. We support all these tools. Anything that can be Dockerized, you can essentially run that. And underneath all this is the Epic platform. You can think of this as Kubernetes before Kubernetes. So the company Blue Data was doing orchestration, container orchestration with Docker before Kubernetes really took off. And they basically created their own container orchestration framework, which is called Epic. And what this allows is that this has got, this can very well support on-prem infrastructure. This can support GPU as a service, different storage options, and it also supports public cloud. It's available on AWS Marketplace, for example. So the idea here is how do we support all these different frameworks for all these different users. And this is what Blue Data tries to do. Underneath, as I was saying, we have different innovations. Elastic Plane is essentially that orchestration. And IO Boost and Data Tab are IO optimizations that we are providing on top of, to allow easy access and secure access to the data. Because if you think of the, data science sort of platform, it's essentially a data lake, right? You can have petabytes of data lake, but you probably don't need access to all that data in a single instance. You need to have access. You want to move compute where the data is. And this is what Data Tab tries to provide. So it will ingest the data into a local store, essentially into NFS, cache that data for you so that you get good performance, and then you can use that iteratively. And these are some of the, in terms of functionality, things like, connecting to cloud, resource scheduling, high availability for enterprise deployments, networking, etc. All these things we do under the hood. And these are very difficult things to do, things like Kerberos, for example. If you have PII information, how do you Kerberize those servers? How you make sure that you have right Kerberos server ticketing mechanism, etc. to do that. So all that we handle under the hood. I'll skip this. And how we provision the software, how do we provision all these different frameworks, as I was saying, we're agnostic to it, is through the App Store model. So essentially as a user, let's say you want a Cloudera cluster, you quickly go into the App Store, you log in as your end user, go to Cloudera, click, and say, well, give me a cluster of 10 compute instances, maybe a few GPU workers, and spin me up a Cloudera cluster, and Blue Data will handle that for you. Just to give you an overview of what we are now thinking in terms of for the future roadmap, Kubernetes is obviously gaining a lot of traction. There's a lot of work that's ongoing with not just in machine learning space, but also in HPC. So, for example, Slurm right now supports, or I think the new version is looking to or will support Kubernetes. And we have a lot of requirements coming in, for example, from Mark, looking at Singularity, looking at Kubernetes. And, Kubernetes is essentially an orchestration engine. It's not, scheduling is just one part of it. Orchestration is all about how do I spin up, if let's say my machine fails, how do I, in a transparent fashion to the user, spin up other machine, move my container over there with the storage. And this is very difficult to do in Docker world because containers by design were supposed to be ephemeral. You just write data. Some people say stateless, but that's not true. There's some state, but that is ephemeral. So how do you make state persistent? And that there's a whole lot of work that's ongoing to make, how does Kubernetes handle storage, etc. And those are some of the things that we provide under the hood for this. We already provide that through HDFS and NFS. In future, recently we acquired another company called Mapr, which were their own Hadoop distribution, and there's their file system. MapRFS was one of the key file systems that is used, and now we are going to support MapRFS as that data lake platform as well, and then allow persistence through Kubernetes, through persistent volume mechanism through that. So this is key. So just to give you an example of what how MapRFS is different is, A classic HDFS has got this problem of name node. So you have a primary name node, secondary name node. If the name node fails, it's essentially the metadata component of your HDFS. Your name node fails, your cluster is out. You will not be able to access any data. That's why you need to have secondary name node, but getting that is very difficult. MapRFS doesn't do that. It basically shards the name node data across different machines, so there's no single name node, there's no single point of failure. The data, the metadata is distributed essentially. And how it's managed is through this hierarchy of data, through blocks, chunks, and containers. And what this essentially allows is that it allows really high performance, scalability, throughput. We are looking at something like 16 gigabit per second on a single MapRFS client. It's similar to what Lustre does through Lustre Client on a single MapRFS client, as opposed to, I think, 2 gigabyte per second, which is on HDFS. So we are almost 8 to 10 times faster that way. And yes, we can present this as an NFS gateway, so that you can use this. One important thing is that this is fully POSIX compliant, so you can use things like cat, VI, file, all that kind of stuff, which you can't do on HDFS. I think my time is up, but I will quickly try to just go to my call to action. So just want to say this, that AI HPC convergence is talked about a lot, and maybe this is happening at infrastructure level. We want to see how we can go up the stack at workflow and application level, and this is what we are trying to do through MapRFS and Blue Data, to provide that seamless experience to end users. And this is a great time, as Mark was also saying, that I wouldn't say we have everything figured out. So this is where we are trying to do a building block approach. There's no one size fits all in this space. So what we are trying to do is we are creating all these different capabilities in different layers of the stack, if you will, and this is where we have this opportunity to co-design something that is custom for your requirements, and this is something that hopefully we'll do with Mark and his team as part of the world-class digital infrastructure, to co-design a stack that can handle the smart city requirements, containerized deployments, and so on for AI and machine learning. And of course, and then how do we incorporate elements of Blue Data, MapR, and create an existing portfolio to create this both generic cluster architecture as well as a specific architecture. So the actual product roadmap will be announced at Supercomputing. I think it's in Denver, right? Not in Austin. I think it's Denver probably. And if you can't attend it, then there will be HPE cast that will kind of go over it. And if you want some more information, then Jan, Simon, and Ben are here as well, my colleagues, so they can talk a lot more about what we are doing with Cray. Thank you so much for your time.